Good evening, everyone. So today's webinar on physical design will be delivered by Mr. Rajesh, who is working as senior physical design engineer with strong hands-on industry experience. He will be sharing how to get into the domain, current trends, and more. So before we begin, I request all the participants to keep their microphones muted. And at the end, similarly as the before 2 days, we'll be having a question answer session. Then you can ask your queries. Rajesh, sir, are you present?
Hello.
Yes, sir. You can take over the session now.
Yeah. Hi. Good evening, everyone. Let
Good
me
evening,
share
sir.
screen.
Good evening, sir.
Hello, sir. I think you are muted.
Hello. Hello. Am I
Yes, sir.
audible
Now
now?
audible. Now it's
Yes, sir.
audible.
Okay. Okay. I'm sharing my screen. Okay.
Yes, sir.
So everyone, are you able to listen my voice now?
Yes,
Yes,
sir.
sir.
Okay. So let's start with the today's session. Actually, today we are going to discuss about the VLSI, and in that VLSI, especially in a physical design, where most of you are interested. Actually, I'm assuming, and these are all the things what we are going to be discuss today, because like I'm assuming a lot of you are from recently graduates, or few of them looking for a courses to take, or few of them still decided something like a VLSI and physical design, and thinking what are all the things will be there inside, and how the industry ongoing in the coming days, and what are the changes we may expect. So those things we will discuss today. So first of all, let's start with the VLSI. So I know like a lot of, I think all are college graduates, and I'm assuming you all are from a EC or triple E background. Like most of them are looking for a VLSI course actually. So that's why you guys already know about the what is VLSI. So VLSI means like very large scale integration. That means like very large scale of integrated circuits were uh, designed to perform a some similar kind of tasks. So here, if you observe, the entire VLSI works on transistor. So in the transistor, maybe in your college days, you might have learnt about the MOSFET. But nowadays, that MOSFET, we are not using that MOSFET. We have so many FETs now, like GAFET, FinFET. So these kind of so many transistors were there now, because like that MOSFET is having lot of drawbacks. So that's why they designed more advanced transistors now. So the VLSI in terms like uh, it consists of million billions of transistors, and these transistors are combined into a chip. Okay, so what VLSI engineer needs to do? So VLSI engineer needs to do is like in VLSI domain, preferably like we are going to discuss about the ASIC, because this physical design comes under the ASIC development. So in ASIC there will be two different uh, ends actually, front end and back end. So front end in the sense like suppose when you need a chip, so for the chip you need to decide what are all the specifications you want and what are all the uh, on what purpose you are uh, developing, or what on what purpose you are creating that chip. So based on that purpose, they will do lot of research and they will try to design a architecture and they will try to write a code for that. So that is why like front end, most of the stuff is regarding the coding and designing the circuit and all. So everything is like just in a it needs a lot of coding actually, lot of coding and Verilog especially. And uh, from front end to back end, wherever you go, the basics will be common and the basics everyone needs to learn. So this VLSI means like combining lots of millions and billions of transistors into a chip. Okay, then where we are using these chips? So we are using these chips and wherever now in the modern electronic devices, wherever it needs. Like for example, if you see in all our smartphones and laptops, everywhere we are using these chips. And you know now like lot of cars having this automation, and now we are seeing the driverless cars, and we know so many features in the cars, like for example ADAS, these so many features in the cars and which requires a automation. So wherever the automation is required, the definitely the chip needs to be there. So that is why in nowadays that demand for chips was huge actually, and it is started actually now only, because so many automation is not only in the automotive electronics, and like in a lot of factories and wherever, everywhere the automation is replacing the humans. So that is why now chips having more demands. So now we know, right, like AI in data centers, AI now, AI, what is AI? So AI needs more competition. For that, they need a more chips. Okay. So because of this AI, lot of fields are struggling, but this VLSI, uh, but this AI needs more VLSI, more kind of complex designs, more kind of complex designs and more kind of competition, everything is needed. So that is why the chip demand is more because of this AI also. And a medical and industrial ecosystem. So medical and ecosystem, now nowadays when you enter into the hospital or anywhere, lot of things are automated, and to do the diagnosis of anything, then lot of missionaries are there, lot of examinations are happening. All these things are possible because of these chips and all these required a chip. So that is why nowadays the uh, demand for these chips were drastically increased. And right, like these chips are not even manufacturing in our India. There is no chip manufacturing unit in our India still now. But right, lot of in upcoming days, lot of uh, chip manufacturing units are establishing in India. So we need more designers in the sense that more VLSI engineers are needed. So that is why everywhere everyone is talking about this VLSI course nowadays, and it is evolving now, and so much of recognition is happening, and a lot of people are showing some interest to be here in this VLSI domain. Okay, so that is why whoever thinking to choose this VLSI domain, uh, you have to uh, you have to be like whatever you are learning from your colleges, whatever you are learning in your academic, everything we are using here in VLSI. And whatever the field you are looking for VLSI, it is going to be very, very uh, demanding in upcoming days. So now in VLSI, especially you guys all are interested in a physical design. So what is mean by physical design? Physical design is a stage in an entire ASIC design flow. So in ASIC design flow, there is a sub design. That sub design, there is a sub domain that is called physical design. So first of all, if you want to learn about the physical design, you need a better idea about the ASIC actually. So ASIC means like application specific integrated circuit. That means for this ASIC, already the predefined application was defined by the designers, and for that application only we are designing our chip. So entire this ASIC development process will work for that functionality what they have already decided. And these ASICs were like faster and very efficient, power efficient, and general chips actually. Power efficient in the sense like, right, nowadays like battery backup and everything is more important. So that's why power efficient also very much required now. So this is ASIC flow. So in a physical design, the chip what you are going to design is called ASIC. So that is why in that entire ASIC development cycle where we are as a physical design engineer, if you look at it, this ASIC design flow, first we will start with the system applications and architectural design and functional design and logic design, circuit design. So first of all, what is this system specifications? So when they decided to uh, build a chip, when they decided to uh, create a chip, first they need one problem. For that problem only, they are creating a solution through our chip. For example, if you are designing a mobile chip, so for that you need specifications. That means like what are all the functions you are including in that mobile chip. Suppose you need a Wi-Fi unit, you need a Bluetooth, you need a camera. So all these specifications you have to decide, and they will decide all these specifications before they are creating the chip. Okay, that is these system specifications. And not only the camera and not only the features in that chip, they will decide about how much area of this chip going to be, and how much power efficient, how much power this chip will consume. So all these things they will estimate and they will decide at the time of the system specification only. And then whatever the specifications they have decided, and for that they will do architecture, and they will create some block diagram of rough estimated diagram for their reference, and how this chip will work and how data flows from one block to another block. So this kind of architectural representation they will make. And next one is functional design and logic design. So functional design and logic design, that means like whatever the futures, whatever the specifications they have decided already, so for that specifications they will try to implement a functional logic. That means they will try to implement a code, Verilog code. And that means like they are writing a code for the circuit, whatever the circuit we are going to be, because like directly they cannot make a circuit. First they want a logic. That means they will build through a programming language and they will test it. First of all, the function, whatever the functionality they are already defined, so it is working or not, or this chip needs any correction. So these kind of betterment, for a betterment they will do testing, right? So for that purpose, if you made any chip and testing, it is very costlier, right? So that's why first they will try to develop a logic, and by using the Verilog code, and by with that logic, and they will test lot of things. This functionality and the design logic, this is what there is another domain called verification, design and verification. So those front end people, we can call them as a front end. So before the physical design, everything is front end. After from physical design to everything below is called back end. So from front end they will do the coding and they will do the testing as well, through some generating some waveforms and giving them as an inputs, uh, and they will verify whatever the functionality they have decided, that is working fine or not. So everything they will test through it. And after the functional design and logic design, the circuit design in the sense like from that RTL code, whatever they've written, Verilog code, that code is converting now into a circuit in the sense it is also in a form of a code only, but the code consists of entirely standard cells. You mean standard cells means like you guys are like, suppose if you are not taken any if you are aware, I think AND gates, OR gates, are all the logic gates and all the flip-flops. So all these kinds of logic gates will be there in the circuit. Okay, so the circuit designing was like just they will create a circuit with the all the logic gates based on the whatever the functionality they need. Now the main thing, the physical design. So from physical design, everything we will call as a back end. Okay, so whatever the front end people did, so uh, all those things were which required more like more on simulation testing and everything, which is a logical thing. That is, they cannot see any physical objects in the design, they cannot see anything, they just written a code and that code they are testing. So everything in terms of logic they are testing. But when it comes to the physical design, the real layout was created, the real chip was created with some height and width and everything. So whatever the physical designer going to be designed, that chip will be manufactured directly. Whatever you are placed, wherever you however you design your circuit, the circuit will be directly manufactured like that. So that is why from physical design to everything below that is called a back end. And the physical design is like they will give you a circuit and they will give you a one area, and they will tell you like, in this area you need to place this circuit. That circuit will consist of these logic gates in the sense standard cells, that is like a AND gate, OR gate, NAND, NOR. So all these logic gates are universal gate, whatever. That circuit consists of all these gates, not only in number of 100 or 200 count. The count will be around uh, 30 lakhs, 40 lakhs, 50 lakh cells. 50 lakh cells will be there in a single circuit. Okay, that circuit will be given to a physical design engineer, and that physical design engineer needs to place that circuit inside a chip, inside the area whatever they given, and they need to uh, do the routing in the sense there will be a connections in the route circuit, right? So all those connections, everything they need to made actually. So this is very complex process actually. So that is why the physical design engineer is a different domain, and it needs a lot of learning and a lot of process, and it will take randomly, if you consider on an average for physical design itself, it will take around 6 to 8 months sometimes, and most and sometimes 1 year also they will take to do this physical design. So that much of complexity will be there in the physical design, so that much of efforts we need to put while learning also. So after the physical design, we will discuss about this physical design later. After the physical design, just as there are sign-offs, that is called like lot of verifications, like lot of testings actually. For every testing, there is a separate domain, but that is a like a it won't be there in all the companies. In a major companies, like there is a separate domain for each testing. They will take care of this testing. If anything they found bug in the testing, again they will come to the physical design and engineer to fix that. So so physical verification, like lot of not they mentioned like a physical verification, but there are lot of verification process will be happen there in terms of timing, in terms of these physical things, and in terms of power, in terms of functionality. So all these things will be verified after the physical design. This is called a sign off stage. So after verification, if anything is comes anything issue they found, and again they will come to the physical design, and physical design engineer needs to resolve those things. So that is why all these sign-offs also very much important to the physical design engineer. Whatever the issues found by the sign-off support team, like sign-off people, the physical design engineer needs to resolve those things. So that is why while he designing the chip, and he needs to uh, keep in mind that there is a verification for everything, and you need to resolve these, and what are all the issues you might get while doing this designing process, you need to be able to resolve all those things. In that way you have to keep in your mind, in that way you have to design a chip. And after this verification and layout and processing, layout post processing, so what they will do is like after we did the physical designing of a circuit, that means physically we created a circuit on a chip. Like they will give an area and they asked us to create, right? So that is also not physically we will do. There will be some EDA tools. In the tools we will do this designing. Okay, there is no physical activity involved here. Everything through a EDA tool, a software which we will do through the our laptop. So in that tool only we will do this designing and all. But physically we are creating a circuit in our mobile, in our laptop now. So this circuit will be, after the physical verification, this circuit will be fabricated. Fabricated means the fabrication is nothing but a manufacturing process of the chip is called a fabrication. Okay. So fabricated, and then packaging and testing. Packaging in the sense like the chip needs to be packed with the some protection, and all the input and output connections needs to be established like this, or however they're shown in here, right? So like this. So this packaging and everything is happens. Okay. So this is the ASIC. ASIC is like just a chip. ASIC flow. ASIC uh, development flow. ASIC life cycle actually. So next, everyone, like we are discussing about the physical design. Why? What is the physical design? First of all, physical design is nothing but the conversion of gate level netlist into a layout. That means you will receive a circuit. It is a, it is like just a code only. Just you will receive a circuit. In that circuit will consist of thousands of transistors, not thousands, lakhs. Some lakhs, 10 lakhs, 20 lakhs, 30 lakhs, some lakhs of transistors it will consist, and some all this circuit, what you need to do is like you need to place this circuit and you need to create one layout. Layout is nothing but a chip you need to create with that, and you need to place that circuit inside a area whatever they given, and you need to ensure the focus is on most like physical design engineer, we will call physical design as a PNR stage. That means place and route. Place and route is nothing but placing all the standard cells, whatever the elements in the circuit inside the chip, and routing in the sense wiring, connecting them with the proper width and length. Whatever we are doing the connections and whatever the placement we are doing in the physical design, that going to be manufactured. So that is why we are ensuring that chip can be manufactured without any issues. And after manufacturing also, that chip needs to be work in multiple years, right? Not only one single 2 years, it needs to work multiple years, like sometimes 8 9 years 10 years. The in the all these years, the whatever we design, it needs to work. So in that way we will design our chip. So logic and RTL and logic synthesis, logical design, here the thing is why physical design is that much important in the sense like front end, that means RTL and logic synthesis they mentioned here, right? That is logic design. Whatever they are doing is like just a code, and they will verifying it. If they found any bug, and again they will do that, they will do a verification. That won't cost any for anything for them. They can do anything because everything is in terms of logical form only, right? So it is easy for them to redo the things and correct the things if they found anything. But when it comes to the physical design, we are the physical design engineers, we are the one who decides the chip future. However you designs now, it will be manufactured in a future and it will be used in the mobiles and laptops. If it is not working, then the blame is on physical design engineer. So that is why the physical design engineer is like real chip layout. We are creating the real chip layout and we are converting this logic into a manufacturable silicon. That means silicon in the sense chip, manufacturing silicon. So now when it comes to the physical design flow, so as a physical design engineer, what we will do in the industry, what we are going to uh, design in our industry. So first of all, as a physical design engineer, you will be seen as a back-end engineer. In the back-end engineer, you will receive a circuit from the front end, and not only a circuit. To start the physical design, you required lot of input files. Input files in the sense like we required 4 to 5 files to start the uh, physical design. For example, you need a library in the sense like in your circuit consists of AND gate, OR gate, and all these gates, right? So how you know the which gate will have a how much power consumption for each gate, and how much time the gate will take to process the signal, and what is the height of the gate in the sense here I'm mentioning gate means gate is a any standard cell. Let's take an example for a AND gate. In your circuit there is a AND gate, but when you are designing the circuit, which is you need to place that circuit in the layout, right? So when you need to place that AND gate in your chip, that means you need to know about the height and width and the functionality of that AND gate, and what are all the inputs and what are all the outputs, how this how much power is consumed by this AND gate, and uh, how much power is required here to operate this AND gate, and how much delay was there inside that, how much delay it is taking. So all these things you need to know, right? So for that we require some other input files also. uh, so we can name them as a library file, logic library, physical library, and constraint file, that is called SDC constraint file we can call. So all these things, all these input files are required to start the physical design. So eventually as a physical design engineer, you will receive a input files from the front end and from vendors and whoever given you the work. You will receive a input files from them. So when you receive input files, the first thing you will do is like a partitioning, because the entire chip can't be designed by one single engineer, because the chip was not that much small as you think, because the entire full chip consists of around some crores of standard cells, some that much of very big circuit it consists. And not only in terms of very big, there will be different blocks in the chip, and which need to be designed separately. So that is why the entire chip was designed, entire chip was uh, made into a small partitions, like small, we can call them as a blocks or partitions. Okay, so each part will be given to a one physical design engineer. So in a entire that physical design life, like physical design, like suppose duration that may be, for example, 6 months or 8 months, you will be owner of that single block, that means single partition, single part in the chip. So that's why like they will make the entire chip into the multiple pieces, multiple blocks, and they will assign each block to a each physical design engineer. As a fresher, you might take one you they might give you one block to design. Sometimes you might need, they might give you two, three, four also, based on the complexity, based on the difficulty of the chip, the block you got. So those many blocks they will assign to you, and you need to take care of all the physical design implementation of that block. Okay, so now after the partitioning is nothing but, for the partitioning, it is not mandatory to know about this partitioning for every physical design engineer, because as an entry level, this partitioning will be done by the most senior persons, like suppose maybe your team lead, or maybe your manager. So those kind of top level people will do this partitioning. As a physical design engineer, if you enter as a junior physical design engineer, or a grad, or as a fresher level, they will assign you one or two blocks from that one. The partitioning won't be done by these junior level people. Okay, and the next thing is the floor planning. In the physical design flow, the next thing is floor planning. Floor planning is nothing but like you will have a one I told they will give you one area. So you have to define that area, like what is the width, and creating that area, what is the uh, height and width of the chip they given to you. Chip in a sense like that, your block, your partition, your small part, chip width and height of that one, and how much uh, and next thing is like the input and output connections for that one, we can call them as a port, we are calling them as a port here, input and output ports. We need to define the input and output ports. Okay, and there will be a, I told like they will give you one circuit. In that circuit consists of all the standard cells. Standard cells are nothing but and gates, or gates are not, are all the logic gates, right? So not only that stand logic gate, there will be some bigger cells also, which is called them as a macros. Macros in the sense like they already predefined, already physical design was done for that small, that blocks actually. So we will consider that bigger cells, and we need to place that bigger cells first. Those called macros. The macro placement we will do during the floor planning. So these macro placement in the sense, these bigger cells in the circuit, you need to place those bigger cells. The bigger cells placement will be defined how the remaining cells will place inside the your chip. Okay, so this is the floor planning, because I'm not telling in the deep actually, because like I'm giving a rough idea what is going to be there in the physical design, what we need to do. So that is why I'm not going much deeper into that. I'm giving a brief idea on what are the things we will do roughly. So we need to place the bigger cells in the core area, whatever the chip we define, that is we call as a core area. So inside the core area, we need to place all the uh, macros, that is bigger cells first. And the next one is placement. The placement was done by the tool only, just we need to tool in the sense like for the physical design, we will have some tools actually, that is called just softwares. Through that softwares only we will do. Okay, So here the placement in the sense like when you after the floor planning, just you can give the one command, just one command. This command will uh, place all your entire your circuit into the block. That means into the your core area. Just one single command. But however you did the your floor plan, based on the your floor plan, all the cells will sit inside the your core area. Sometimes that area is not sufficient. Sometimes like you might have placed all the cells one single area and left remaining things are empty. So these kind of things will happen and you will get a lot of issues in the placement, like in terms of timing in the sense like signal needs to come from input to output with specific time, right? It cannot go whenever it want, it cannot come whenever it want, right? There will be a specific timing and there will be a clocks. So based on the clock and uh, based on the frequency, the timing needs to be met. So everything depends on the placement of the standard cells, and the placement of the standard cell is depends on the floor plan. So that is why each and every stage is depends on the prior stage. And if your every stage you are doing better, then the next stage will be good. So like this is the placement, like just all the standards will place inside, and lot of issues, whatever the timing and congestion, we can call as a congestion, because if you places too many cells at one area, then the tool or whatever, we cannot do the routing, or we cannot do the wiring for all the standard cells properly. So which will create a congestion. So these kind of issues we will face in the placement. So that is why placement also very much important. If your floor plan is good, then your 90% your placement also will be good. And then the next stage will be CTS. CTS is one of the important stage in the entire physical design, because like CTS is nothing but right, like when you studied about the flip flops, for the every flip flop or any kind of sequential cells you might have known in your from your academics, definitely we need to give the clock signal as an input for that. So CTS is nothing but building the clock tree. Clock is nothing but a pulse signal what we are giving. So this clock is a reference for our entire block. That means like at what time we need to give the inputs and what time we can expect the outputs of, at what time cell needs to be on, at what time the cell will receive the input, at what time the cell needs to send the output. So everything that there needs to be one reference, right? So this CTS is like, this clock is like a reference for all those things. So building a clock tree, that means like we need to build the clock network in the design after placing of all the circuit elements inside that. And in the circuit there will be a lot of sequential elements, right? So all those sequential elements needs a clock. So we will build the clock tree for all the sequential elements. So that is why the clock is very important, because based on the clock our entire circuit will be operated, and the speed and functionality of our entire chip is depends on that clock signal whatever we are giving. So that is why the clock is very important. That's why there is a dedicated separate stage for the clock. So that is why CTS stage was there. After the CTS, in the CTS also we have some, we definitely for each and every stage there will be some targets and goals which we need to overcome. So we need to same like in CTS also there will be some goals like insertion delay, skew, all those things we need to take care that. Maybe most of you don't know about the skew and insertion delay. Once you familiar with the physical design flow and everything, then you might know that and you can understand that easily, but which is very important here. So the CTS, in the CTS, skew and insertion delay are the targets, and building the clock tree for all the sequential elements. So we can do that. So that is why there is a separate stage for that. And next one is the routing. Routing is nothing but now you place the entire circuit inside the chip and there is a connections for that. So for that connections you need to do the proper connection. Now connection is nothing but there is just a simple logical, like there is a we can call them as fly lines, or we can call them as net connections. It will show some indication which cell is, which input is connected to the which output, like that. Then the routing is nothing but making a interconnection with the proper width and length, because the wire is having the width and the wire is having the length, right? So with the proper width and length, we need to make connections for all the elements in the circuit. All the inputs and outputs are connected now in the routing stage. Previously also the circuit was there, the connection was there, but which is just a uh, logical connection is just a connection was there, but which is not established with the proper width and length. Okay, so in the routing, the all the connections were routed in the sense, all the connections were with the proper width and length. All the connections were made properly. So actually, when you start a career as a PNR engineer, from the floor plan to the routing, the PNR engineer job was done. But there is a sign offs. In these sign offs, there will be a 5 to 6 checks. 5 to 6 separate domains are there which will check our functionality, which will check whatever we design. So all these sign off teams will design. All the sign off teams will check the chip what we design, and if anything issue they found out, again they will come to the physical design engineer, and the physical design engineer needs to fix that issue whatever they found. So that is why now, as a physical design engineer, you need to have an idea on the sign off as well. And not only in some companies there will be a separate teams for sign off to do the checks and all, but so in some companies physical design engineer only needs to do the all these sign off checks, and he himself needs to fix all the issues. So that is why it is very much important for the physical design engineer to learn the sign off also. So this is about the physical design flow. And actually, if you see this one as a flow from partitioning to the sign off, hardly it will take, if you take maximum time, it will take 1 week only. But it is not the case. The when you start the actually everything we will design, we will do in a tool, right? So if you give it to the tool, then tool can do from start to end. It will take around only 15 days. But the thing is, it will be having lot of issues. To resolve these issues, again multiple iterations you will do. Again, like suppose you are starting with the floor plan and placement and everything is done, and routing you found some issues, again you have to go back to the floor plan. So this kind of iterative process will be there in entire physical design life cycle. Okay, so in this entire, like suppose you started one run in the sense like one run from the floor plan and placement is completed, CTS routing everything is completed, but in routing you found issue, again you have to go back to the floor plan. And suppose in middle placement itself you have found out, again you have to go to the floor plan. So like this, you need to design the chip in a iterative manner. So you have to design for something and you will check that, and if it is okay, then you will look forward, and again you have to go back for something else. So everything will be done, redone, like everything will be automated, like you have to do repeatedly until everything, every violation, everything remains zero. Every violation, there won't be any violations issues, any issues in a chip, in your chip, and everything was fixed properly, then only you can move forward actually. So that is why it will take mostly or more than 6 months and more than 8 months, like that it will take to do the PNR for one single block. And next about, so why this physical design is more very much important nowadays. Why this physical design is important? This physical design affects the chip power and design, because like whatever the front end guys are designed, everything is in terms of logic code, and they can do whatever you want. But here, as a physical design engineer, you are creating a chip, and you are with some area and some real chip you are creating, right? Like whatever the wherever the components you want, you can place them there, right? So the physical design affects the chip speed and power, because if you are not doing better, Suppose your design was not that much good in terms of speed and power. When they manufacture your chip in terms of, then it will affect the chip speed and power, then it won't work properly. So that is why this physical design is very much important. And based on the physical design, the chip production cost also, and if the chip was working fine, then the chip will have a more value. So that's why this physical design decides the chip cost also. And this is the final step during before the manufacturing. Whatever the physical design engineer doing, that everything will be manufactured as it is, however you design. So that is why it is the final step in the manufacturing process. That is why it is very important for the physical design engineer to work very uh, uh, we need to you have to make sure there won't be any flaws or there won't be any issues in the layout. So that is why it is very much important thing. So why everyone, like lot of people are choosing the physical design engineering? So as you know, like physical design engineer is like a very high demand skill, because like you know, right, the physical design domain, a lot of people are choosing the physical design because like it is very demanding in the sense, not in terms of maybe as a fresher you might have thinking like you are saying it is high demanding, but lot of freshers are waiting for the looking for the opportunities. As a fresher you need to wait for few days, or few months, sometimes years, until you get a chance to prove as a fresher. So once you enter into the into the industry, you need to spend at least 3 to 4 years in a company. And then if you see the demand for experienced people outside, then you will know how this, why we are mentioning here this is a very high demand skill. Okay, so there is a lot of demand always for the experienced people, but for freshers it is less. Not only in a VLSI domain, in everywhere, the for the freshers it will take time. But in a physical design, in a VLSI, it will take little bit more time than others. But after the once you enter into the industry, if you spend some more years here in the industry, then after you gain some experience, then you might everyone knows why this is that much of demanding skill, because that much of opportunities will be there, and that much of, not only in terms of skill and growth I'm talking, I can tell in terms of commerciality, like in terms of salary wise and everything. Uh, this is far away from all the very much further from all other domains actually. So that is why this physical design, and not only in terms of money, like a lot of people like whoever studied EC, Triple E, they might have a very much interest on the core domain, like whatever we studied that we need to work on them only. So that is very much interesting, and that is why a lot of people are shows interest on the core domain. That is why core semiconductor role is like so many people are choosing. And long term career growth, that is what I mentioned. Once you enter into the industry, once you gain a so much experience, and you want not only experience in the sense like not only in terms of years, how many years you spend in the industry, that is not an experience. Maybe that might be useful for you show in your resume, but the experience in terms of uh, how much you learned when you are designing, or when you are doing your, when you are facing the challenges, how much you learned and how much you spend time on the designing process, and how many techniques you followed, like whatever you are doing, what you learned from the mistakes what you did. So these kind of learnings, the experience I'm talking about. So if you have that much of experience and you can show that skill to your interviewer, or you can show that skill to your team leader, whatever, and definitely you will reach the places where the a very good in terms of everything you will receive very good reception actually. And long term career growth. And you know, right, this is the physical design and the back end thing we are doing. That means like whatever the it is a hardware designing, right? It is a hardware designing, but we are designing through a software. we are not doing hardware design in the sense we are not going to the factories and we are not doing designing, right? We are doing through a software, but it is a hardware designing, right? So that is why it is a hardware. It takes more time to do any reforms. Like suppose if you take an example as some software sites, in sometimes like one programming language will have a more demand. In sometimes like then it will fade out and some other new language will come. It will change very quickly. But when it comes to the hardware designing, it is takes more time to replace something. So that is why in a core domain, in a physical design, or I'm talking about this hardware designing, it will take more time to change something. So that is why there will be a very long term career growth here, uh, very long time growth here. And next thing is like satisfaction, whatever right, like nowadays everything is automated and every uh, for example, if you take in your home also, every appliance is now automated, everything is having some it is connecting to some Wi-Fi or something. Android is there inside. So wherever the Android, wherever the automation is happening, everything needs a chip. So everywhere the chip is need. Say the career, then it is a common sense that we can think the career. We have a lot of careers to career, a lot of growth in this career. So that is why everyone like interested to choose this one. And not only the what I discussed, right, like we don't have any single chip manufacturing unit in India, but lot of companies are started their uh, establishing the manufacturing unit. So that is why like this VLSI making lot of noise now, and everyone is looking at this side to choose their growth career option. And so we discussed everything about like there will be a lot of growth and there will be a lot of salaries, and there will be like this is like it won't be changed quickly. There will be a lot of career here, like that. But there are so many realities, like we have to. So you need a more benefits. You need a more benefits. Like then you need to put a more efforts also. So that is why this is the reality of a semiconductor industry. So learning is important. Always you have to learn, and there is a vast learning here. So much of things to learn. Okay, so it requires a patience. It is not like a just I joined a course or something. I just graduated. I joined a course and I completed it in the 2 months, 3 months. I need a job. It is not like that. After completion of your course also, you need continuously how to learn until you get a opportunity. It might take more time to get the opportunity, but once you get the opportunity, after that, once you got somewhat experience, then the future will be very good actually. So that is why there is no shortcuts. Everything you have to learn, and you have to, through your skills only, you can get the job here. That's why patience is required, and you need to spend more time on learning yourself. And strong fundamental matters. Why I mention strong fundamental matters here is like whatever you studied in your college, like for example digital circuits and analog circuits. I'm talking about analog means like in a physical design, even though it is a digital designing, we required analog also somewhat. So we need for example, in your basics, you need around 70% digital design you need to learn, and 20% analog you need, and 10% remaining other things. And tool is also having tool in the sense like whatever the software tools we are going to use, EDA tools. So strong fundamentals needs to be there. Okay, as a fresher. So skills needed, not tool. So like when this is most important thing I need to tell you here. So when the person, anyone like he takes the course, and what they will do is like they very keen on the tools. First they will take the tool and they will try to do everything in the tool, and they thought okay, we did, and we learn everything. It is not the thing. Tool is secondary. First you need to learn the basics first, and all this you need a digital electronic basics, very strong digital electronic basics. and understanding the timing concept. Timing in the sense like in the chip, how the timing is, like there will be some calculations and there will be how the timing is behaving. You need to understand these timing concepts, like there will be setup and a hold. Like if you take the course and if you, I think if you learn about this physical design, you will learn about what is setup and hold and everything. And then logical thinking in the sense like you if you face any problem, how you will resolve it and how you can think and how to resolve that, and what are the things you need to use here to resolve this issue, and what are the things affecting what are the causes for this one. So like that logical thinking is needed here, and problem solving mindset also needed, not directly the tool. Okay, so that is why the tool whatever here is, that is secondary. First you need to more focus on these all these things. And the students needs to be prepared strong basics in digital electronics and learn how circuit works actually, because a lot of you are in a colleges, maybe just lot of you are in a final year and looking for the course, then it is time for you to learn all these things, because like in your college also they might have taught this, but again it is very much important to learn all these things when you are coming to the course. Okay, so strong basics in digital electronics, learn how circuit works, like right, how the resistance and capacitance will be there in the circuit, how this resistance capacitance will affect a signal going in a wire. So all these things you need to learn, and understanding of this clock and the flip flops and the timing and everything is important here. So all these things everyone needs to be prepared well. And how should student prepare? So how every student needs to be prepared? Learn the VLSI flow conceptually. Like I told ASIC flow. In the ASIC flow, physical design was there. So first you need to learn about the ASIC flow and then physical design in deeply, and what are the stages are there. So in the, that is why everything you need to learn in the flow. So then only you can remember and you can understand the concepts easily. And the role of each stage, there are different stages in the physical design also. So why there is a different stages, and why they have they divided in a stages, what is the role of each and every stage. So like that you have to learn actually. And next thing and last thing is like this one, avoid memorizing the commands. Like we are using the tool, right, to a lot of work we will do in the tool only, but the tool will works with the commands. So don't try to remember the commands. Just if you want a one command, just get it through the tool only. Because like suppose if you have a one doubt, like suppose for example I can tell get cells, you simply you can get that command through the tool only. So that's why don't try to remember the commands, just try to how to get the command from the tool itself. That is why everyone in interview also directly, if they will ask you, if they asked you a very big command, then you can tell I didn't remember the commands, I know the command how to get from the tool, I know I can get. Like that you can tell, no issue. And not only in terms of not only in terms of uh, digital electronics and analog and everything VD, not only those things, we require these basic things also in a VLSI and physical design, because like basic Linux usage actually, it is not like don't afraid of like Linux. Okay, we need a software, that kind of, no need to afraid. Okay, this Linux is nothing but the whatever the environment we are going to design our circuit, that environment will be in a Linux actually, because the tool what we are going to use, that cannot be installed in any laptop, that will be installed in the server. Okay, you have to connect to the server and you have to work in that server only. So that is why the environment will be in a Linux operating system. So that is why you require some basic Linux commands, or how to use, how to open a file, how to create a file, or how to read a file, how to open a file, how to edit a file. So these kind of small uh, Linux commands only we required. Hardly if you remember 25 to 30 commands of the Linux, then that is more than enough. And next, coming to the TCL, why this TCL is needed? TCL is a uh, it is a scripting language. Actually, it is a front end. Why like it is a software language we require
Hello, sir. Your microphone is muted.
Sorry, sir, you're not audible right now.
now. I'm audible.
Yes, sir.
Yes.
Okay. Is my screen is visible?
Yes, sir.
Okay. So actually, as a physical design engineer, we are discussing like we need more in terms of uh, this one analog and digital and physical design basics and physical design flow, ASIC flow. But why we need require this TCL? Why tool commanding language? Why we require this one? Because the whatever the tool we are going to be use, that is maybe you might have no ICC2 or Fusion compiler, or from the Cadence you might have Innovas. So these are the tools we most probably we will use in our industry to design this chip in a physical design. So these all these tools will work on these commands only. The syntax of that commands will be in this tickle format. So that is why we needed some basics in the tickle format, not only for the commands and not only to operate the tool. For example, you need to do any automation. For example, I told in your circuit there will be a uh, some lakhs of AND gates. For example, suppose you are having 10,000 AND gates, you need to change the um, type of AND gate. For example, there will be different types of AND gate. You need to change the AND gates, or you need to get the information something from the 10,000 AND gates. You cannot do for each and every at single time. It will take 10,000 time to click there and check that information, right? So if you know this scripting, then simply you can write some small code and small script, then the script will give you the information for about the 10,000 cells. So that is why this tickle is needed. So if tickle is there, this TCL is there, then your work will be little bit easier to do. Okay. So that is why we are learning, and the commands also follows this tickle syntax rule. So that is why it is important to learn this tickle also, and learn debugging approach. Suppose you got an issue, then how to debug that? What is the first you need to find out the reason for the issue, and then you can find out the how to resolve this issue. So that is why you need to learn the debugging approach also. And common mistakes everyone will do, chasing too early. That means without learning the fundamentals and everything, and they are like, just I want a job and I will apply for whatever I come. So you are applying, right? There will be very less, like very limited number of opportunities outside. And maybe if you are wasting your opportunity, means like you are just missing your job opportunity there. So that is why before chasing and before going into the any interview, or before applying for all the companies, first make sure that how you are, like how much confidence you are, how much prepared you are. And first thing you have to keep in your mind, whatever the first interview you are getting, in that first interview itself you have to get the job. Keep that mind in your mind. So prepare like that. So you won't get that many chances here, you will get a less chances. In the first chance itself you have to get the job. So keep that mindset, then only you can learn, and keep learning. And if you learn like that, then uh, you will get the easy. So that is why you don't ignore the fundamentals expecting quick jobs. Like it is not quick here. So when you, because it will take times, actually it will take time here, but once you get it, the future will be very good. comparing too much. That is the one other thing is comparing too much. Like suppose you might have graduated from your college and you have to taken this VLSI. One of your friend may be taken in a software company, software course, and within 4 to 5 months he got the job, but you didn't got. So you are comparing with him and he got the job, I didn't got the job. But it is not a case here. Maybe you might take little bit more time compared to him, but after few years, for example after 3 years, his salary remains like whatever he joined, or he might be having around uh, 1 lakh or 2 lakh more than that there. But there is a if you compare the salary after the him after the 3 years, it will be sometimes almost double of him. After 5 years, every time the salary will be double of him maybe. So that is how, like, don't compare too much about the other things. So keep learning and keep trying, exploring the a lot of options wherever we will having, suppose any fresh any. And another important thing is, like, suppose you learned in the physical design, and if is there any opportunity in a PV, that is another verification domains like PV, RV, or some other things also there. If there is there an opportunity on that sign offs also, you can go, you can. But main thing is, like, you have to enter into this industry. That is important. Don't tell like, I want only a PD engineer role, I don't want any PV role, I don't want any RV role. Don't tell like that. If any role is there with respect to the back end, just go and join. Because as a fresher directly won't make you as a PD engineer, and they won't give you the block, and they won't make you a block owner. You have to work as a support engineer for first initial 1 or 2 years, then you will become a PD engineer. So that is why just entering into the industry is important. So you can start as a sign off engineer, and then you can come as a next in upcoming in next project, maybe you can take one block and you can become a physical design engineer. That is not an issue. So that is why first keep in mind, entering into the industry is important, not the domain. Maybe it is a synthesis or whatever it is there, you have to enter it. That's it. So again, the choosing the institutions, like a lot of people are thinking like, we in college also we can learn, and we can learn self learning, we can do all these things also. But why this training institutions are very important, very much important nowadays is like, they will know how the industries are operating, what are the industry is looking for, and what are the things they need to train. So that's why there will be a structured learning path will be there in institutions, and they will give some industry oriented, like suppose how real time work is going on, how, in a real time, how they are designing everything. So that kind of orientation, that kind of structured and learning path will be there. So industry oriented curriculum will be there, and not only about the subject, not only about this learning, and main thing is mentorship and guidance, because they will guide you. Like there will be, like suppose in a next few months there will be opportunity in this company, you need to prepare like this. That kind of mentorship and guidance is also very much important in VLSA, because it is very small industry. So that is why we required more mentorship and guidance also. So that is why these training institutions also will place a major role in your career. So next one is like how this physical design is evolving. Actually, see, nowadays now these chips are becoming very complex. Complex in the sense, right? I mentioned here advanced technology nodes. That 7 nanometer, 5 nanometer, 3 nanometer. That is size of a transistor gate. Every transistor will having one gate terminal, right? That gate terminal length will be, that is it. It is most probably the MOSFET or whatever the FET transistor size was this. So now the size of the transistor is reducing, and that means they are making more complex. That means more number of transistors in the less area. The chip size is very less. They want chip size is very less, but more number of transistors and more number of features they want. So that is why this design, physical design, and this backend is evolving like this, and faster delivery. Because right, some companies will have a will take around 8 to 9 months to complete this physical design. Some companies will take 5 to 4 months. They need to design they finish it by 4 months, 4 months, 3 months also. Some companies are doing that. So that kind of faster delivery requirements are there by some of the companies. So that's how nowadays, like advanced technology nodes are now 2 nanometer, 1.8 also doing some companies. So this kind of uh, evolving is happening here in the physical design. So challenges, what are the challenges? Like timing margins, like I told, frequency will be there. Now the higher frequency designs are there. The timing margins are very less, and power and reliability issues. Uh, Power and reliability issues in the sense like now operating power is very less, and if any design is consuming more power and it is not using nowadays, we require very less power utilization because battery backup is more important nowadays. So we cannot make any errors. So designs are very huge designs in the sense like more number of functionality is there, more number of standard cells, more number of cells, and very big circuits actually. So that is how nowadays we have. And now it's come to the AI nowadays, like right, in AI is impacting in all the domains. Like so many domains are impacting by these domains. If impacting by this AI, right, like a lot of software domains are like shrinking because it's AI. Like we are hearing a lot of AI is coming and a lot of people are losing their jobs. So these kind of things we are listening daily. But here in thing is like how this AI is using here. Here, yeah, AI is using like to reduce the manual efforts. Like suppose I told the physical design flow and each and everything is physical design engineer needs to do. But there are so many automation things we can do through the AI, and we can do the like speed up the design cycle. Like I mentioned, from the placement to floor plan to the routing or sign-ups, we can speed up that one with the AI, and we can expect some more quality and handle complexity better. And if you have more complex designs with the AI, you can handle it better. Uh, Suppose what is the role of AI in physical design in the sense like makes a better decision, and suppose I told everything is repeat. Suppose once you found out the issue in the routing stage at the last stage, and you have to go back to the first stage. This repeated process will be there, right? This is we can call as a trial and error. There won't be any specific rule to design here. You have to follow the rule, but if you face error again, you have to go. That is like just a trial, making a trial, and if and trying. That is the trial and error method. So whatever we are following is trial and error method only. Okay. So because of this AI, we can reduce the trial and error method and improve the productivity. And next one, what AI will not do. That means like a lot of people are thinking if AI comes, then lot of jobs are going. What about this AI? So here, AI will not do any design architecture, and AI will not take a ownership. I told for every block there will be block owner. He is the responsible for entire designing of that one single block. That means one part of the chip. So AI won't take a ownership like that. So AI will not replace engineering judgment. So judgment is very much important, which is good, and how we need to proceed with here. Lot of complications are there inside. Once you come to the industry, only you will know. So it cannot be done by the AI actually. And impact of AI on PD jobs. Engineers become more productive nowadays. Okay, so because like engineer is this AI is just helping the engineers, but not it is replacing the engineers. Okay, because like engineers become a more productive because of AI. Fewer iterations. That means it is reducing the time, okay, how much time it will take, and it is making faster to market. So the product it will take 1 year or more than 1 year, 2 years to comes into the product, right, into the market. So because of the AI, maybe it might be faster to come into the market. It is increasing that speed actually. And PD jobs remain strong, so there won't be any replacement for the PD because of this AI, because it is very complex thing and it cannot be done by the AI. So AI is a helper, not a replacement. finally. So AI is a smart assistance. Okay, it can assist the engineer, but engineer is the final decision maker. So final responsibility is human only, not AI. And my final advice is like focus on fundamentals, choose the learning over shortcuts. Don't think for the shortcuts. Choose the learning is the process. Try to learn, and like you have to learn everything. Whatever the suppose you are telling any definition, you are seeing any definition. For example, there is a anything is there for a definition you are reading, you have to learn about each and every word in that definition, because in interview there will be a lot of questions, right? Once you comes to here, like here the interview will be a more around 1 hour interview, 45 minutes interview. And when, because like as a fresher there will be some exams, like a written exam, and next round is will be sometimes uh, written exam, and next first round will be written exam, second round will be um your interview. But when you come when you become an experienced engineer, then when you uh, changing your job, that time the interview will be, there will be 2 to 3 rounds of interview only, and 2 hours 3 hours interviews will be there. So that is why basics are more important, so learning is more very much important here. So don't try to choose the any shortcuts methods and all. Try to learn and be patient and present. So be patient until you get your chance, and until you get your uh, chance to prove, and grab the first opportunity whatever you will get. That's all about today's session. So if anyone having the all the best for your journey. Okay, so I'm everyone, like whoever thinking to start their career, and some people may have finished their career, like their learning and all. So all the best for everyone. So if everyone anyone having any questions and all, they can ask.
Hello, sir. This is Nagesh. First of all, thank you for taking the session and
Yeah,
guiding
yeah,
us.
hi. Yeah, hi.
Sir, as a fresher, like on campus placement, do
Okay.
do we have to um, do we have any projects on PD? Like, do they see any projects upon PD in my resume?
Actually, if in basically PD requires the software, right? I told EDA tools, whatever we are using, maybe ICC2, Innovas, or it is rare that we can see them in the colleges. So if you are doing any project in your college, and which is on back end or PD or any VLSI, it is advantage only. Now, definitely they might have seen, like they will see, because like lot of companies are now doing hiring from the colleges. Like suppose right, once upon a time, like in a long back years, like this VLSI was there in all the medium range companies. I'm talking about only service based companies. It was there in a medium range companies. Nowadays all these software gain companies were there, right? Like this Wipro, Capgemini, and this Wipro, Capgemini, and Tech Mahindra. So all these big companies are buying small medium range companies. And now what these big companies are doing is like just they are going into the colleges and they are hiring from there also. But it is not that much, it is rare actually. So if you are already trained fresher, that means you are already taken the course, then that is your advantage for you. But
Yes.
if you are they are taking from the college, definitely if you are in your resume, if that is there, suppose you did something project in your academic related to the VLSI, then that is definitely an advantage for you.
Yes, sir. If I have the projects regarding the only front end, like a processor RISC-V and FIFO and AMBA protocol on SoC, if I
Okay.
have projects and I
Okay.
don't have any PD project, then will will be a like how they will consider me like.
Actually, enough your college hiring process, I think first they will start with the written exam only, right?
Yes, sir.
So maybe you might have you might have done project in a front end, but whatever the basics you learned from your college, that basics will help you to clear the exam. Then only they will, if you clear that exam, then they will see your resume for interview round, right? Technical interview.
Yes.
That time they will see your resume. If they found out like you did a front end, that is fine. Like they will ask you questions like you did a front end project, then you are interested in the back end. What is the reason? Like that they might ask. Then you can tell like to do the back end project, it is very difficult in the college level, because that tools whatever required to do the back end, that is very
It's not provided in our college.
yeah, in any college they won't provide that kind of tools actually in colleges. So that is why
Yes, sir.
yeah.
Thank you.
Sir, I
Sir,
have
apart
one
from the
question.
sorry, sir, apart from
Yeah.
the tools, sir, what are the open source tools we can go through for the PD roles? Like we can do other things.
Open source tools, I'm not sure about open source tool, because I didn't use it that open source tools actually. So I'm not sure about that open source tools, whatever now available. I'm not sure about that actually.
And sir, can open source tools may help or is
Yeah,
it relevant?
open source tools may help you definitely, but now you know, right, like in a physical design or in a back end, that getting opportunity is very much important. And in a outside scenario is what happens is like some companies are going for the drive for particular institutions only. They are taking from the, like they are asking like from which institute you trained, like you trained pressure or not, you learned yourself, like that of questions they are asking. Like suppose if you're trained from some other institutions or some other guidance, then that is a benefit for you only, na? So if you want to learn yourself, then that is okay. But that open source tools are not that much uh, competitive compared to the VLSI, that industry oriented tools, because like whatever the tools you are learning in your industry, in your institutions, like suppose you joined any course, there you will get a tools, right? The same tool you are going to use in companies also. That is why that tools are important than the open source tools.
Hello, sir.
Yeah.
So I'm a trained fresher.
Okay.
Okay, I want to know the one thing. Like recently, I completed one project. I want
Okay.
to know how would be the debugging approach. For example, post loading stage, if any max trans violation is occur, how to find the actual culprit of the violation? Because I can't blindly apply any technique like
Yeah,
engineering
yeah,
principle.
definitely. If you found any issue, not only max cap or max 10, whatever if you got any issue, directly you cannot apply the remedy for that. It is not blindly we cannot apply. So first you need to know what is the issue for that, what is the cause for that. Suppose you are telling input transition, for the input transition, the signal which is coming from the driver cell, that previous cell, that signal is not good. So that is why you are getting input transition, right? So first of all, you need to check the driver, whether the driver is low drive strength it is having, or maybe the net is too long. Okay, so first you have to you have to check the net length, and then the driver drive strength, and then the driver fan out. So all these things you have to check. Then if everything is okay, then you have to check that cell. Maybe that cell also sitting too far, or you did something mistake in the floor plan. That way also you have to think. But when you're thinking about the fixing in the routing, in the sense like you might have done better job in the floor plan and everything, then the fixing tran is like just you have to see the net and the driver cell. You have to upside the driver cell if it is the issue, or if the having long net, you have to add the buffer. So that is how you can approach.
So how should a designer should know it is a long net like a
Outside
threshold
designer,
voltage?
sorry.
So if I am a like if the net is there, certain length is there.
Okay.
How I should know this is a long net based on the net topology?
See, what is the driver cell is there. Okay, the driver cell, will have a drive strength.
Yes,
So
Darshan.
drive strength. So you might have know that how much, like suppose if it is having a 4x or 5x drive strength, and how much length it can drive. Suppose the length is like more than 50 microns or 60 microns, okay. But if length is more than 100, then that is the issue.
Okay.
So
Then we
that's
have
how
the
you have
inside
to take.
buffer.
Suppose if you are not aware, if you are not aware of that length also, whether it is good or not, take
Oh,
another cell as an example, which is having better tram. How much net length is there? How much net length now I am having? Compare both. So that way also you can get the idea, right?
okay. Sir. Thank you.
Hmm.
So I have a one query.
Okay.
I have a trained fresher in PD only. It's becoming almost of 1 year.
Oh,
We are not getting any opportunity. Could you please tell me the key points for these things?
actually, opportunities wise, like when you finished your course, or from when you started looking for a job.
In Jan only it's completed. It's becoming if it's 1 month is this December is completed means it's becoming 1 year. I joined
You
in April only, 2024.
2024 April, and it completes on January. So
Yes,
you passed out on 23rd or what?
23rd only.
23rd only. Like uh, in LinkedIn, you have to see like lot of opportunity. I also seen like, right, like
But
in
we are
LinkedIn.
waiting for N-log layout only. In PD, we have a requirement on 2 years plus and 3 years plus only there. Opportunities are there. There is a no opportunity
In
2023.
your training institute, they didn't provide any placement for you.
They are providing, but due to the some glitches and or from company's hold, they are telling the mail size from company only we are getting hold requirement.
Yeah, maybe. Yeah, definitely. The recruitment was little bit slow. Happened from past
Yeah,
1 year.
in my training institute only I got from around 8 companies. Till now I didn't get any return from that one.
So anyone selected from in that 8 companies?
No. From 2 days back I got one mail from company only. The recruitment is already closed.
Oh. So opportunities wise, we cannot give a guarantee like when this will increase, but hopefully in the next year, like because in past 1 year we didn't see much improvement, much recruitment, right? So that is why hopefully like when this kind of hold is happened for a longer period, in the next year might you can see more opportunities. But as a you have a gap, career gap, like you completed your graduation 23rd, right? You have almost 3 years, right? You will get better opportunities. Actually, you have to see in a LinkedIn, and you have to apply. What you have to do is like if any mail you have seen like fresher, suppose don't try for a big companies. Any small startup also fine. Okay, apply for the any startups, and you have gap. Actually, like recently graduated students is, for them it is little bit difficult for a get opportunity. But when you have this kind of gap, so they will take you easily actually. So that is why keep looking in the LinkedIn, or keep like some other sources, like if you know any seniors, or if from an institute, from anywhere, try to send your resume and ask them, I have this much gap. Okay, so that is where you will get better opportunities actually.
Other than LinkedIn source, we have another resource to apply the
No,
application.
actually, most probably, what they suppose, if they don't find any candidate in the LinkedIn, then only they will come to any other domains. Actually, there are a lot of people in LinkedIn itself. Like they will get, suppose, for example, one company need 5 to 6 people. They will get it from the LinkedIn. Why they will post it in the some other platforms also. It is there, but very limited
But
actually.
I heard from someone they are telling in LinkedIn will get very less chance in to
Okay,
get.
then whatever the platform is there, then you can try from there itself. Na? What's stopping you from doing that?
Okay.
Yeah, try like that. Continuously try that, and if you get any opportunity, don't lose it. Actually, so in that way you have to prepare. Don't like giving an interviews and just missing. Okay, just you have whatever the opportunity you are getting, the first opportunity itself you have to get. That's like that you have to prepare.
Okay, thank you.
Sir, I have a doubt actually.
Okay.
Sir, recently Synopsys has posted a job for design verification.
Okay.
I have applied to the job through via referral
Mhm.
from one of the employee from Synopsys.
Okay.
But even though I have applied through the referral, I have gotten rejection mail. That
Okay.
so what is the uh, fault behind that?
What is the tool you used in your training?
Sir, I have used training like Synopsys ICSE 2, like for and also I have used it for Xilinx ISC
Okay.
and
I
Cadence.
don't know, like, suppose you applied, but in what terms of rejection is happened, we cannot tell you, right? Like, what their requirement is, we don't know, right?
So it's for
Yeah.
internal actually.
Yeah. Maybe they are looking for, like, suppose they might have very less opportunity, first of all.
Okay.
Okay. So they might have given preference to any NIT, IIT students.
Sir,
That is also possible.
actually I am from NIT.
Okay, maybe okay. So NIT students itself, like they got rejection. Maybe their requirement is maybe some other things, or they not at all hide anyone. So we cannot tell what their requirement is, right?
Okay, sir.
Mhm.
Good evening, sir.
Good
Yeah.
evening,
Good
sir.
evening.
So first of all,
Actually, he
the
mentioned
session is so insightful.
Sorry.
First of all,
Anyone? Sorry. Yeah. I'm not able to listen your
hello,
voice. Yeah.
hello.
Tell me. Tell me.
I'm audible. So
Yeah.
the first of all, the
Yes.
session is so insightful. I understand every part and parcel of the PD. So my doubt
Yeah.
is, I'm
Mm.
about to graduate in 2026 year. So
Okay.
what are the options I need to choose? I mean, I have two options: going to the training center or pursuing my higher studies and getting a good job in the MNC. So I have two options, two ways. So as you are experienced, right? I need some guidance or
So
feedback.
from which college you are studying? Like any
Tier three, sir.
third
It's yes, sir,
tier
tier
three? Yeah.
three. Yes, sir, tier three
Type
college.
3, like if you have interest, you can go for that. Uh, but there won't be
Hello, sir.
more preference for MTech students. Like what happening here, I will tell you.
Okay, sir.
If you graduated from the MTech also,
Mm.
then you taken a course. So you want go through from the placement you're talking?
Yes, sir, yes, sir.
Okay, so is like not much recruitment happening through the campuses, are right, for physical design. You want
Okay.
any other domain or
Yes.
physical design only?
Uh,
Or
no, sir. I need to enter into the VLSI industry. So it's a booming career, right? That's fine.
yeah. So you can take like you can take the MTech and parallelly you can try for the opportunity, right? But it is not that much practically work.
Yes, sir.
So in my thinking, it is better to start your career. I cannot tell that one because I can tell something it will affect you in other way. So I cannot because you might have taken serious decision on my words. Then
No, sir. Your decision is considerable amount
just
successful.
yeah. So in my case, what I will thinking is like starting early is
Mm.
fine. So okay, even though if you do, I will tell you one thing. Even though if you do the MTech,
Yes, sir.
suppose again you want to pursue the course,
Yes, sir.
you can start it from the MTech first year itself. After the first year,
Okay.
in second year itself, you can start your course
Okay.
parallelly from online or
Okay.
anywhere. Okay,
Okay.
then you can try from there. What companies will take? They will take the freshers of MTech because that MTech 2 years gap is there, na.
Yes, sir.
So the what companies will see is like whoever having the more gap from the academics to now, they will prefer
Okay.
most probably them actually.
Okay.
So that way also you can try. That is another thing actually in my
Okay.
point of
Okay,
view.
sir.
Just you.
Okay, sir. Thank you, sir.
Oh, thank you.
good evening, sir.
Yeah, good evening.
Sir, as you mentioned that a role is not important, but entering to the industry
Yes,
is important.
yes.
Some of my uncle also suggested that now companies like Micron Technologies they are hiring graduate engineer trainee roles.
Okay.
So can I start my PD career through this role? What you
So,
suggest?
so, so my suggestion is they told the role is graduate training, but
Yes, sir.
where?
Graduate
But
engineer
in
training.
which field? Like in ASIC, in back end or front end, where they mentioned
Back end only, sir. Like
back end only.
troubleshooting, debugging, testing. These are the roles for chip manufacturing, like DRAM cells.
Okay, the troubleshooting. See, I told is like in a physical design there are sign off. You know, right? You
Yes,
already
sir.
trained, I
PV
think.
check cell. Yes,
So
sir.
PV will be there, RV will be there, IR, sorry,
Yes.
IR will be there, or
ERC. Yes, sir.
STA will be there, okay, and VCLP will be there, and
DRC.
DRC, that is PV actually, okay.
Yes,
So
sir.
all these sign offs I told actually, RC, this one, synthesis also fine. So
Okay.
if PD is your main domain, these are all supporting domains for that, right? So if you get any supporting domain, also fine. But I whatever you are telling, like I don't have much idea on that. Actually, it is related to the PD or something. Suppose maybe post silicon verification. That is
Yes,
some different story actually.
yes, sir.
So that is what my
Okay.
I yeah.
Sir, also you mentioned that they check for gap between education.
Mhm.
What they will do with that gap, sir?
I don't actually. This lot of service-based companies will take that them only actually.
Oh, okay, sir. Thank you, sir.
Uh-huh.
Hi, sir.
Hi.
So, from your experience in physical design,
Okay.
at what stage do this physical design teams or the design verification teams together typically collaborate? And what's the one thing you actually wish for the DV engineers to be to be wisely understood about the physical design constraints?
Actually, this design verification and PD will not. They won't meet actually. That is like first design verification. People will do this designing and verification for this RTL, and they will give it to the physical design back-end engineer. If anything issue they found out, again they will contact with the. So in that way, they both will meet. Uh, w-
Okay.
in that way they both will meet actually. Nowadays it is not like DV and like RTL is designed by someone and next given to the physical design engineer. It is not like that. Both are happening parallelly now. Just they will write some basic RTL and that will be given to the PD team. Then PD team also working parallelly, and this design verification team is working on remaining RTL things actually, and they are giving this RTL into the PD engineers and like incremental RTL. I can say they are giving some other extra things into the circuit. So the design engineers, DV people needs to understand like. Uh, Suppose for example there are issues like LOL issue, because there is two registers, between two registers there is lot of logic, then that is very difficult for PD engineers to meet the timing. So first they have to so that in that way they can do some more work actually to help the PD engineer.
Okay.
Hello, sir.
Okay.
Okay, yeah, hi.
Hello, sir. My question is related to the last participant asked you,
Okay.
and that is actually as a physical design engineer, what sort of coding basics should I need to know? As I don't have to work with hardcore coding like the RTL engineer or DB engineer do. So what sort of basics should I know actually?
No, that DV engineer, those will do Verilog, or I don't know, I think system Verilog, or that is language is different. That is very, that required more coding actually. But here in the PD is like only TCL language is needed. That is also not that much. We need to have just suppose I will tell you example. If there is a code already, because everything is automated now in the industry, flow is automated, everything is automated, right? Suppose if you got an error, then you can able to debug that error from where you are getting error. So that's why some basic um, debugging on that language, just a syntax I can tell. So that kind of basic idea on the tickle is enough. Not that much of deeper developing kind of not needed here.
Hello, sir.
Okay. Thank you, sir.
Okay.
Yeah. Good evening, actually.
Good. Yeah.
I have a question, actually.
Yeah.
I have recently completed my graduation.
Okay.
I gone through with the VLSI PD domain only.
Okay.
Like top institutes are in Bangalore, Hyderabad, and wherever it is.
Okay.
They are providing like curriculum in only all institutes are providing only one project only for PD.
Yes.
That is, I will have to explore as not I don't know actually. That is the archetype only design.
Okay.
All the students are doing analyzing same things only.
Yes.
Then what's that the recruiter expecting from the candidate? Same that means that thousands of people and candidates are
Yes.
analyzing same work and
Yes.
again doing something. If that
Yes.
and also only it is going on like this.
Yes.
Then
Yes.
what they will expect from the candidates?
So actually design might be same. Design might be what you
Yeah.
told, same design. All the institutes are doing the on the same design. But the thing is in that same design also, you might create a problems and you might create a problems and you can explore the problem and how this problem is like suppose I can say an example. You can create a different kind of core area also, right? Different shapes and different kind of floor plans. And now you can observe what kind of issues you are getting. Okay, so in that way you have to explore more on that tool. In industry wise, in an interview they will ask, they won't expect much from you as a fresher. They will expect you, suppose for example in a placement, what kind of issues you have faced, and if this issue comes, what you will do. So that kind of analytical thing they are expecting from you. So everyone can tell the same answer, everyone cannot tell the same answer, right? So suppose you created a core area in a different shape and you got some other congestion, you can tell that scenario in the interview, where not like you have to think like that. So you have to create a problem yourself and you have to explain in that way actually. So that's why like okay, he is capable of understanding the problem, he is capable of, he can analyze the problem and he can conclude it and he can find the solution for that problem. So you have to tell like that actually. Understood?
And also, actually,
Hello, sir.
Hello?
so
Uh,
competition is actually
Sorry?
uh, like from 2023 pass outs and 24 graduates are placing actually.
Okay.
But as we come to graduates recently graduated, they are like career-based companies are playing
Sorry, your
game
voice is
actually.
too much noise and I'm not able to understand what you are telling.
Yes, sir. Now what?
Yes.
2023-22 pass outs are getting opportunities in a good way.
Okay.
As for the graduates, they are struggling too much,
Yes.
and also service-based companies are they providing actually expecting experienced candidates only.
Okay. Okay.
Is there any opportunities for next year, starting onwards 26 onwards? We will see any opportunities, and
So
also
if
market
you
is
are a 225 passed out, then next year like you will be having already 1 year completed, right? So you also are having 1 year gap now. Then next year you might see some more opportunities actually. That
and
every time
also
is like
in market nowadays there are two NN chips, right?
sorry,
In market we are seeing two NN chips, right?
12. Sir, I'm not
Two
able to.
two NN chips, two NM chips, right?
Yes, yes, 2 nanometer.
In further, any updates on we are going undergoing in microchips also, like micro
Micron? I'm not able to.
Microsoft. Okay.
Hello?
Hello.
Hello? Yeah, hi.
Yeah, good evening, sir.
Good evening.
Sir, actually, when companies came for on-campus placements,
Okay.
so as a fresher, like what company expect from us? Like because the company only tell that they are coming for only digital, ASIC digital roles and all. So, but
Yes,
in
yes.
yeah, but in this digital, we also have like design verification and PD also. Like they didn't tell the specific role. They will tell after the placements and all. So, sir,
Okay.
like, yeah, what they want to see the things in our resume, like what is skills, like they want to see that Verilog system Verilog and
Hmm.
the projects of PD2
Hmm.
and also the projects of Verilog system Verilogs
Okay.
and also the tickle and all. Like, sir, yeah, what they want
So,
to see in the resume.
so actually, what I want to see in a resume in the sense like it is based on the which role for they are coming. Maybe it is for the PD role or maybe for the DV role. If I was from, if suppose if they are coming for the PD role, then what they will see is like uh, common thing is like if they are for the DV or PD, they will see your skills in a digital design. That is like your mm, design, this one digital electronics and analog electronics. This is a common thing. And again, like suppose if they are coming from the design verification side, the your programming coding knowledge in a Verilog or system Verilog, and how much like right, uh, finding the logic for any particular code. So that kind of things they will see if it is a DV role. Suppose if it is a physical design role, they will see most probably very basic concepts like how the transistor will work. So those kind of basics they will expect from you, and they will suppose if you have more idea on that PD flow also, you can learn the PD flow at least. Then what are the things will be there? So then they will expect that, because like after finishing your graduation, then you are thinking about the these opportunities, right? Then you know, right, what are all the domains are there outside. Suppose VLSI front and back end, then learn about the front end as well and back end as well, not very deep. That uh, uh, not very deep actually. In rough idea also you might have, you can learn like from internet also you can get more information and you can learn, right? So in that way you can keep there in your resume like I did something, I learned about the VLSI flow, like that also you can keep, right? That will be somewhat benefit for you only.
Okay, sir. Like if anyone is doing the course of RTL to GDS, then like if I have completed a project based on the RTL to GDS, then I think there is no need of any certificate of RTL to GDS. Like if we are doing from NPTEL and all.
Yeah, it
So
is yeah, no need of anything, but uh, if you are did through the NPTEL, from NPTEL also you can get the certificate, right?
yes, sir.
Yeah. So suppose like if you learn through your own, or suppose there is a two candidates, one learn through your own and one learn through the institution, then first they will suppose they will see your this one written exam and the interview, and then final there what they will choose we cannot tell, right? Maybe they will go like, suppose if he trained from the institute and he might have a real time exposure. That is the important. You did the project in your college, but when you train in the under any trainer or any institution, then they will tell the real time problems what they are facing in the industry. That problems and that solutions they will ask particularly in interview. So that is the most important thing actually.
Okay, sir. Sir, one last question. Uh, like, is there any research paper that is relevant to industry? Like we can write if we want to in the physical design and all.
Sorry.
If we want to write any research paper which is relevant to industry, So is it good?
I'm not aware of that. I'm not. I don't have any idea on that actually.
Okay, sir. Okay. Thank you so much, sir.
Yeah, thank you.
Hello, sir.
Hello.
Sir, I think we can.
Yeah,
wrap up
yeah,
for
we
today.
can. Yeah,
It's
we
already
can.
time.
Yes.
Sir, one last question, sir.
Okay. Last. Okay.
Sir, my name is Manoj. I am a third year student.
Okay.
I am joining at a VLSI PD in any institution. It's my fourth year first sem. It's correct or not?
Sorry.
I am a third year student, sir.
Okay.
I think I'm joining some training institution in the VLSI PD in my fourth one semester
Okay.
in offline. It's correct or not in your field?
Actually, if you completed your graduation, also suppose you finished your graduation and you training within that time only, then what you will do after that? There won't be that much of hiring for the fresh graduates, right? So is there is a chance definitely you can place after the graduation also, but it is very rare cases. So first you can focus on your academics and finish them, and then you can take the course. That is also one option, because like anyhow after your graduation there will be some time for the companies won't take that fresh graduates, right? You are seeing the current scenario. So that is also an option. So, and another thing is like if you completed your course in the but my thinking is like, suppose when you parallelly learning your academics and this course, but you cannot put more focus on this course. That is what I feel. Okay.
Yeah, okay, sir. Thank you.
Yeah.
Hello, sir. Sir, we can wrap up for today.
Yeah, we can wrap up for today.
Yeah.
So thanks everyone for the joining. Thanks.
Yeah, thank you, sir. Before concluding, I would like to extend a heartfelt thank for you for engaging the
Thank-
sessions. It was very
Yeah.
insightful, and thanks for your patience for addressing the queries till
Yeah,
now.
thank
Yeah, thank you all for joining the session and being a part of this webinar. Now all can leave.
Yeah, thank you.
Thank you, sir.